Hi everyone. This is the limit definition of a derivative explained by Calculus Tutor. So the first thing to note is actually the formula for the limit definition, and it is the following. It is the limit as h approaches 0 of f of x plus h minus f of x over h. So we are going to use this, and the purpose of it is to find f prime of x, which is the derivative of a function f of x. So let's take a look at a few examples. So the first example we might see is given that f of x. So the first example we might see is given that f of x equals x squared, find f prime of x using the limit definition. So let's try that. So if we take a look at our limit definition, we already have f of x. That is given to us right here. H is just a variable by itself. And the last thing that we need to derive in order to use this formula is f of x plus h. So how are we going to get that? We're actually going to get it ourselves. And here's how we're going to do it. If we wanted to get, for example, f of 4, all we would do is plug in f of x. Here, we would plug in 4 for the value of x. So for the same reason, if we want to get f of x plus h, all we're going to do is take our f of x and plug in x plus h in for our x value. So we're just taking that x and subbing in x plus h. So now we have it. Now we have f of x plus h, f of x, and h. And now we are going to rewrite our limit definition with this filler in mind. So it will be x plus h squared minus x squared over h. And something to note here is if you actually try to just do direct substitution, which is probably the first thing you'll want to try to do with limits, you will see that the h gets substituted to 0, and this will be 0. And then this will just be x squared minus x squared, which is 0, and then over 0, which is an indeterminate form. So that's not what we have to do here. So this basically means we have to use some kind of manipulation to this function in order to simplify it. And how we're going to do that is we are going to FOIL out this term right here. So x plus h squared, if you know the simplification, it is x squared plus 2xh plus h squared. But if you don't know that simplification, you can also just FOIL it out. So x times x is x squared, x times h is xh, h times x, I'm just going to write that as also xh, and then h times h, that is h squared, which gives you the form x squared plus 2xh, combining these two like terms, plus h squared. So that's what we are going to simplify this as. So we will write that up top. So it will instead turn into the limit as h approaches 0 of x squared plus 2xh plus h squared minus x squared over h. And now all we're going to do is combine like terms and then simplify from there. So we see that the x squared minus the x squared, those cancel out and those go away. So what you are left with is the limit as h approaches 0 of 2xh plus h squared over h. And again, if you try to do direct substitution here, you will just get this h is 0, this is 0, this is 0, you'll get 0 over 0. So what I would do from here is you see that there is actually a common h term in both of these terms up top. So let's factor that out. So it'll be h times 2x plus h over h. And now you see that both of these h terms can cancel because they're being multiplied. And now you can rewrite it, the limit as h approaches 0 of 2x plus h. And now you can do direct substitution to just get 2x. And that would be the correct derivative, which is f prime of x. Let's take a look at another example. So let's say you're given that f of x equals 3 over x. And they want you to find f prime of x using the limit definition. So let's go over that. Using the same logic as before, what we're going to do first is we're going to derive f of x plus h, because again, that's the only unknown that we need to find in our limit definition. So f of x plus h would be 3 over, and then substituting x plus h for x would be 3 over x plus h. So substituting that all back into our limit definition, it would be the limit as h approaches 0 of 3 over x plus h minus f of x, which is 3 over x, over h. And we can get rid of these parentheses because there is no multiplication or anything that we have to do. So we have our function here, and now we need to simplify it in some way, because again, if we try direct substitution, not going to work. You will get 0 over 0. So how we're going to do this is, in order to add and subtract fractions, we need to get a common denominator. So the common denominator between x and x plus h, the easiest way to think about it is we need to multiply one denominator by the other term in order to make it common. So really, the common denominator between both of these would be x times x plus h. So that's what I'm going to do. So in order to do that, I am going to multiply the first function by x on the bottom as a result, and we're going to multiply that on top, because whatever you have to do to the top, you have to do to the bottom, and vice versa. For the same reason, I'm going to multiply the second fraction by x plus h and x plus h on top and bottom. And what you'll be left with then is we have to simplify both of these fractions. So we think about this first term. Whenever you multiply fractions, all you do is multiply the numerator times numerator and denominator times denominator. So if we rewrote this, it would be the limit as h approaches 0. 3 times x is 3x. On the bottom, we're just going to write it as x plus h times x. And minus, and then 3 times x plus h, I'm going to distribute this 3 into each of these two terms to make it 3x plus 3h, and then over, and then this is x times x plus h, which I'm just going to write as x plus h times x for consistency. And then because of this, and then don't forget the over h, because each of these terms now have the same denominator, now we can combine them. So we can rewrite this as the limit as h approaches 0 of 3x minus 3x plus 3h. Make sure to put that whole second term in parentheses, simply because it is minus the entire thing, and then all of this over h. And how does this help us? Now we can distribute this negative sign to make it minus 3x minus 3h, and then the 3x's will end up canceling. And so what you are left with is the limit as h approaches 0 of negative 3h over x plus h times x over h. And if you were having trouble seeing how to simplify the problem from here, whenever you have a constant times a fraction, so like 9 times 1 over 5, we can rewrite this by putting the 9 in the numerator. For the exact same reason, you can reverse this by taking the constant and moving it out front, or anything for that matter. So for this h here, I'm going to move this out front to rewrite it as negative 3 in the numerator and just h times all this. And this can help you see that because it is h multiplied by all of this here, that means that we can cancel this h and this h to just make it the limit as h approaches 0 of negative 3 over x plus h times x. And now we are simply going to try direct substitution to make it negative 3 over x plus 0 times x, which would just be x times x, which would be negative 3 over x squared. So let's set f of x equal to the square root of x, and let's try to get f prime of x using the limit definition. So what we are going to do for the same exact reason, we are going to get f of x plus h, which would be equal to the square root of x plus h. So what we have then is the limit as h approaches 0 of the square root of x plus h minus the square root of x over h. Again, we're at the step. Do not try to plug in, you can try to plug in h, but you're going to get 0 over 0. So we need to manipulate this in some way. And how you do it in cases like this, whenever you see something with a square root minus another square root or something like this, you need to multiply by what's called its conjugate. So in this case, because there is a minus sign in between these two, we need to multiply by the same exact terms, except change the change the minus sign to a plus sign. And you will see how that works out and why we do that in a second. So let's try to multiply out the top and see how it FOILs out. We are just going to do that by FOILing. So it will be the square root of x plus h minus the square root of x times the square root of x plus h plus the square root of x. So the first term will be the square root of x plus h times the square root of x plus h. And whenever you multiply something by itself, that is the same thing as squaring it. So that's how I'm going to write this term. The next FOIL, we have plus the square root of x plus h times the square root of x. And then we have minus the square root of x times the square root of x plus h. And then finally, minus the square root of x times the square root of x, which would be minus the square root of x, and that would be squared for the same reason. So what you see is these two terms in the middle are the exact same thing, just because it's the square root of x times the square root of x plus h. And since they're being subtracted, these two actually cancel out. And what you are left with is the square root of x plus h squared minus the square root of x squared. And the square root is the inverse operation of squaring, and you can see that these two operations just cancel each other out. And so what you are left with is x plus h minus x. And you can see that these two x terms cancel, and so you are just left with h. So that's all the top simplifies to be. So we have the limit as h approaches 0 of h over, and how are we going to deal with the bottom now? How I would recommend that you approach this is just to keep the h unfactored on the bottom. So just write it as h times, and then all of this stuff, the square root of x plus h plus the square root of x. And you notice that because there's an h term on top and bottom, and they are being multiplied in both terms, you can get rid of them by just canceling them. And so what you will be left with is the limit as h approaches 0 of 1 over the square root of x plus h plus the square root of x. Finally, now that we have simplified, we are going to try direct substitution by just making it 1 over the square root of x plus 0 plus the square root of x. Square root of x plus 0 is just the square root of x, which means we can simplify this as 1 over. This is the same thing twice, so you can just write it as 2 times the square root of x. And that would be your final answer. That is equal to f prime of x. And there you go. All right, let's go over one more example. And this time, we are going to be dealing with f of x is equal to x squared plus 6x plus 5. And we want to find the derivative using the limit definition. So you are not going to be given this formula on a formula sheet, so you are going to need to memorize this formula. So let's write it down again. It is the limit as h approaches 0 of f of x plus h minus f of x over h. So what we need to do is we need to derive f of x plus h, which in this example, again, we substitute x plus h in for x. It will be x plus h squared plus 6 times x plus h plus 5. So let's substitute everything back in to our limit definition formula. So it will be the limit as h approaches 0 of x plus h squared plus 6 times x plus h plus 5 minus f of x, which f of x is this entire thing. So we have to write it as minus parentheses x squared plus 6x plus 5. So again, because you're subtracting the entire thing, you need to put it in a set of parentheses. And then over h. The final thing that we need to do, again, if you try to do direct substitution, plugging in h equals 0, you will get 0 over 0. So we need to simplify this in some way. And we're going to simplify as much as we can on this left side here. So this x plus h squared, we're going to rewrite that as x plus h times x plus h, like last time. X times x, that is x squared. X times h, that is plus xh. H times x, we could write this as plus hx. When you are multiplying two things, you can write them in whatever order you want. So I'm going to rewrite it as xh instead of hx. And then h times h, that is h squared. So this simplifies to x squared plus xh plus xh, that is two of the same term, so 2xh, and then plus h squared. The only other thing we're going to simplify is this 6 times x plus h, and how we're going to simplify that is by distributing the 6 into each individual term to make it 6x plus 6h. So let's simplify this limit. It will be the limit as, and I'll rewrite it on this second line here, the limit as h approaches 0 of x squared plus 2xh plus h squared plus 6x plus 6h plus 5 minus, and we need to distribute this negative sign to each individual term. So minus x squared minus 6x minus 5, and then all of this over h. And now we are just going to combine like terms as much as we can and then simplify from there. So we see here there's actually an x squared and a negative x squared term, so those are going to cancel out. There's a positive 6x and a negative 6x, so those are going to cancel, and you have a positive 5 and a negative 5, so those are going to cancel. And what you'll be left with is the limit as h approaches 0 of 2xh plus h squared plus 6h over h. If you try to do direct substitution here, you see that because each term has an h in it, it will just get 0 over 0. So we need to simplify this in some way. And how we do that is because there's an h term in every single thing up top, we're going to factor that out to make it the limit as h approaches 0 of h times 2x plus h plus 6 over h. And now you can see that these two h terms can cancel out to just leave you with the limit as h approaches 0 of 2x plus h plus 6. And now we can do direct substitution to get us 2x plus 0 plus 6, which would just be 2x plus 6, which is f prime of x. So that is how you find the derivative of a function using the limit definition.